All right, here's problem number 2 from the practice test. Says Jeremy works for a well-known marketing firm and needs to gather information about individuals on a test market for a new client. Jeremy wants to calculate the 95% confidence interval for the proportion of adults in the test market who commute more than 20 miles one way. This is a proportion problem because either you do or you do not commute more than 20 miles. Jeremy is unable to find any preliminary information about what the proportion may be, but he wants to have a margin of error no more than 4%, 0.04. How large must the sample size be? Well, luckily for you, you are given a formula to help you decide that. This is the proportion formula, n equals p star 1 minus p star over z star over me margin of error squared. So n equals p star 1 minus p star times z star over margin of error squared. Now, here's the situation for this p star value. P star is either a proportion given from an earlier study or 0.5. 0.5 is what's called the worst case scenario. All right. Now, since there was no previous study, we are going to use 0.5 and 1 minus 0.5 here. Now, since it's a 95% confidence interval, our z star value is going to be 1.96. And again, that is found on your formula sheet. Over the margin of error, which he wants to be no more than 4%, and we'll square that. So 0.5 times 1 minus 0.5 times quantity. And now I'm going to do, second quit. Sorry, go back over there. I want second that so I can, nope. Quit, try that one more time. I want alpha there so I can get a fraction. All right, and my fraction 1.96 divided by 0.04. I'll set up in the wrong spot. 0.04 over close and square it. There we go. Hit enter. And we get that n must be 600.25. Now, because we cannot have a quarter of a person in our survey, we will round up to the next whole person. So our answer is 601 people. Okay. Jeremy wants to estimate the mean commute distance for the test market. He commissions a pilot with 35 randomly selected adults and finds a sample mean of 12.7. I'm going to write that down. That's a sample mean, so it's an X bar value, and a standard deviation from a sample. So it's S is equal to 9.2. How large must the sample be to have a 99% confidence interval for a population mean distance with margin of error of no more than 4 miles? If we go back to the formula sheet, now our formula is here because we're dealing with means instead of proportions. All right, and it's n equals t star times s over me squared. N equals t star, sorry, quantity t star s over me. All right, so what do we know? Well, I know what the margin of error he wants. He wants it no more than 4. I know the standard deviation is 9.2. But now we have to work on what does t star mean? Now, I'm making a guess here, but I think it's a pretty reasonable guess, is that since we want a 99% confidence interval, so we want the t value that will give us this 1% lower tail. But the problem is there's not one t-distribution, there's many t-distributions based on degrees of freedom. Since we've already got 35 in the pilot study, I think we're going to use degrees of freedom 34 for our situation. So what we want is the lower tail to be 1% in a t-distribution with 34 degrees of freedom. How would we find that out? Well, let's go to second distributions. Let's go to the inverse t function. It asks us for an area. I'm going to say it's 1% area. And I'm going to say 34 degrees of freedom. And then we'll hit paste. So inverse t 0.01, 34 degrees of freedom. Again, this is an area. And this is degrees of freedom, right? And we got a value of negative 2.44. Now I'm going to ignore the negative part and basically say that 2.44 seems like 2.441 seems like a reasonable value for that. Now we're expecting that it's going to get bigger, and if it gets bigger, then it's going to be slightly more aggressive, but we're going to be fine with that. So here we go. We're going to say, let's take that fraction of 2.441, multiply it by our standard deviation of 9.2, divided by our margin of error of 4, and let's square all of that. And in doing so, we get 31.52, which means our answer is going to be you have the right formula there? Yep, that's the right formula. Oh, I know where I screwed up. Sorry. Okay, let's do a correction here. If this is 99%, this is not a 1%. That's a 0.5% or 0.005. So our T star value is incorrect. Zero, second insert 5. So our T star value is really negative 2.738. That's going to make a big difference. 2.738. Okay, there we go. And that gives us a 39.65 value for that calculation. Of course, we need to round up to the next whole value.